Hey, everybody. We are in lesson 10.4 on inscribed angles. So first off, you need to understand what an inscribed angle is. It's basically an angle whose vertex is on the circle. All right, so if you're a visual person like myself, that's an inscribed angle, angle QRS, because the vertex R is on the circle. Okay, what it creates on the circle from Q to S is called the intercepted arc. So the smaller the angle, the smaller the intercepted arc. The bigger the angle, the bigger the intercepted arc. And it's made from the other points where it hits. Like, for instance, I said angle QRS. Q and S is where the angle hits the circle. So that's your intercepted arc from Q to S, or S to Q, whatever you want to call it. Okay, so we got some examples here. These are all inscribed angles. This is a very small inscribed angle where the vertex is sitting on the circle here. So there's a very small intercepted arc. This one's a little bit wider. You'll notice one side of the angle is the diameter of the circle because it goes through the center of your circle. This inscribed angle creates the intercepted arc. Very wide angle creates a very wide intercepted arc. All right. What else we got here? Okay, here's what I figured was coming. This inscribed angle, angle 1, and this intercepted arc AB. You need to know that this inscribed angle is half of the arc AB. So let's say this angle is 60 degrees. It's half of the arc, so it would be 120. The arc AB would be 120. So let's say the arc is given to you as 120. The inscribed angle is half. That would be 120 divided by 2 is 60. Okay. Make sure you guys understand. Oh, okay. Here's one where they have the same intercepted arc. So I'm talking about angle C first, the green angle, which is angle DCA. C is the vertex because that's the letter I said in the middle. But I said D and A, as in DCA. DA would be the intercepted arc. Same thing with this rusted looking orange angle B, angle DBA. I said D, then B, then A, which means B is the vertex. That also is a DA, so the intercepted arc is also DA. They have the same intercepted arc. What the rule is that these two angles are equal to each other. The inscribed angle C and the inscribed angle B are going to be the same. Okay. All right, example number 1. So I'm going to turn the page in your workbook. I was on page 593. Now I'm on page 594. Okay. So let's see here. Find each measure. They want the measure of arc CF. There's arc CF, visual people. And angle CDF is the inscribed angle in which it is labeled 40 degrees. Well, if this angle is half of the arc, then multiply 40 times 2 to get CF. So it looks like 2, what do they want me to do here? 2 times 40 degrees. I wish they'd make this easier to see. This is horrible. And no matter what I do, you can't even see it any better. That's a shame. Now, what if I make it into a new tab? Can I see it better? No, no matter what I do. All right, well, 2 times 40. I haven't put it twice. Is 80 degrees. All right, so this arc CF is 80 because its inscribed angle is 40 times 2. All right, they want me to find angle C, the measure of angle C, which is this angle right there. It's actually angle DCE, and you'll notice that DE is a 98-degree arc. The inscribed angle will be half of 98, And 1/2 of 98 is 49 degrees. All right. So there is the measure of angle C. All right, so it looks like we're done with example number 1. So let's go to example number 2. All right, this goes back to the rule where you have two angles that have the same intercepted arc. Let me shoot back down here. So angle A is actually made from angle BAC. So BC is its intercepted arc. Angle D is actually made from angle BDC. BC is its intercepted arc. They have the same intercepted arc, therefore angle A and angle D are equal to each other. All right, so angle A is congruent to angle, where's my angle sign? D. All right, which means 5x minus 12 equals 3x plus 2. They don't give me a lot of room, do they? All right, fine. Subtract 3x to the other side to get 2x. Add 12 to the other side to get 14. And 14 divided by 2 is 7. All right, we're going to replace that. Looks like they want the measure of angle A. So 5 times 7 minus 12. Well, 5 times 7 is 35. Minus 12 is 23. And they want the measure of angle A. We got 23 degrees. Okay, let's go on to our check. Okay, so I'm looking at angle T and angle U. The first thing I want to do is make sure they have the same intercepted arc. Well, angle T opens up to S and V. Angle U opens up to S and V. I said SV both times. They are the same intercepted arc, which means these two angles are equal to each other. So set 3x minus 5 equal to 2x plus 15. 2x plus 15. Okay, the opposite of adding 2x is subtract 2x. So 3x minus 2x is x. The opposite of minus 5 is to add 5 to the other side. 15 plus 5 is 20. All right, so we got x is 20. They want me to find the measure of angle T. So I'm going to take my 20 and plug it into the 3x minus 5. So 3 times 20 is 60, minus 5 is 55 degrees. There is our check for page 594, example number 2. And let's move on to example number 3. All right, what we got here? All right, we got a proof. All right, so I'm looking at things that are congruent because they're marked equal, like these little 1 slashes and these little 2 slashes. All right, so it says that arc QR is congruent to arc ST. Y'all, that means that angle P, this angle QPR, and this angle TPS are equal to each other. So we've got angles that are marked equal. Remember A for angle. All right, they tell us that arc PQ and arc PT are equal. Well, that means its inscribed angles are equal. So PQ would be angle QRP, and arc PT would be angle PST. That means angle R and angle S are equal. Okay, there's your another A. So we got AA. We got 2 A's so far. All right, then it tells us that QR's segment, this segment, is congruent to ST, this segment. And that comes back from the rule for the lesson before this one, where if your arcs are equal, the chords are equal. And since our arcs are marked equal, the chords that are made up of QR's arcs are equal. And same thing for ST. So our chords are equal. That is the side. So we've got angle, angle, side. Angle, angle, side, everybody. AAS. The angle, angle, side goes right there. And it's not going to let me put it in for whatever reason. I can't type it in, but it would be AAS for angle, angle, side. Okay. All right. An inscribed angle, all the vertices of the polygons lie in the circle inscribed triangles and quadrilaterals have special properties. Okay, basically, you need to know that if one of them is a diameter, like for instance, your triangle is sitting inside half of a circle, like a semicircle, then angle G is a 90-degree angle automatically. This is a right triangle because angle G is automatically 90. For a quad, if it's inscribed in a circle, you know the opposite angles are supplementary. What I'm saying is this. Angle L, opposite to angle N, they add up to be 180. Same thing for K and M. Angle K, angle M, they're opposite. They add up to be 180.
Room 117. Shania Tipton. Lillian Beckon. Callie Whitmore.
Okay, sorry about that, you guys. They were calling people out for makeup EOCs. All right, so where was I? Oh, okay, I'm example number 4. All right, okay, so look, this is a right triangle. And I know that because the rule says that if you have a triangle sitting inside half a circle, in other words, if you have a diameter as one of the sides of the triangle, it's a right triangle. So this is automatically angle L, 90 degrees. What that means to you guys is that the other two angles add up to be 90 because 90 and 90 make 180 for a full triangle. All right, so we got 5x minus 4 for angle K plus angle M, 8x minus 10 equals 90 because they are complementary. Okay, so I'm going to combine like terms. 5x plus 8x is 13x. And I'm going to combine -4 and -10 for -14. And that equals 90. So now you've got 13x minus 14 equals 90. I'm going to add 14 to the other side to be within 90. So 90 plus 14 is 104. Again, I added 14 to the other side. All right, and the opposite of multiplying by 13 is to divide by 13. So 104 divided by 13, 8. All right, they are looking for the measure of angle K, which means now that I have x is 8, I'm going to replace this x with an 8 and find the measure of angle K. All right, well, 5 times 8 is 40. 40 minus 4 is 36 degrees. Okay, looks like, are we done with example number 4? Yes, we are. We have a check coming up. We got to find the measure of angle V. Okay, again, I see this triangle inscribed in a circle. That means all its vertices is on the circle. But I'll also see that one side of this triangle is the diameter, which means angle U is a right angle. Y'all, this is a right triangle. All right, that also means that these two angles, T and V, are complementary. Or you can add up all three and set it equal to 180 if you want to, but the shortcut is these two angles, T and V, are complementary. So I'm going to add 7x minus 5 to the 2x minus 4, set it equal to 90. All right, here it goes. 7x minus 5 plus 2x minus 4 equals 90, or you can add all three to set it equal to 180 if you want to. 7x plus 2x is 9x. -5 minus 4 is a -9 equals 90. All right, the opposite of subtracting 9 is to add 9 to the other side. And that leaves us with 9x equals 99 because 90 plus 9 is 99. The opposite of multiplying by 9 is to divide by 9. And 99 divided by 9 is an 11. But don't forget, we're not done. That is not what they asked for. They asked for the measure of angle V. So that 11 is going to replace x. 2 times 11 minus 4. Well, 2 times 11 is 22. And then 22 minus 4 is 18. We got 18 degrees. There's our answer for the check. On page 595. All right, we are done with page 595. So we're going to move on to example number 5. So I'm on the page 596, everybody. Whoa, that's pretty. All right, we got stained glass. Luca is creating a collection of stained glass ornaments. The ornament shown uses a quadrilateral inscribed in a circle. Find the measure of angle F, find the measure of angle G. Well, first off, what I know about an inscribed quad whose vertices are all inside the circle is the opposite angles are supplementary. Angle D and angle F. They are opposite angles. They'll add up to be 180. Angle E and angle G are opposite angles. They will add up to be 180. And it looks like that's actually how they started this problem off. D and F, they added them up to be 180. So I guess we need to finish out this problem. 5y plus 3y is 8y. 16 plus 4 is 20. All right. Subtract 20 to the other side. 180 minus 20 is equal to 160. Divided by the 8. 160 divided by 8 is 20. So it looks like y is 20. Now they want us to find the measure of angle F. 3 times 20, because I'm replacing y with what it is, 20. Plus 4. Well, 3 times 20 is 60. Plus 4 is 64 degrees. All right, now we find angle G. Well, angle G is opposite to angle E. These angles will add up to be 180 because they are supplementary. That is what the rule says. So x minus 4 plus 3x minus 16 equals 180. Okay, so it looks like they put that together. So 1x and 3x is 4x. Negative 4 and negative 16 and minus 20 equals 180. Okay, so let's see. I'm going to add 20 to the other side. 180 plus 20 is 200. That brings down my 4x. And the opposite of multiplying by 4 is to divide by 4. 200 divided by 4 is 50. So x is 50. Don't forget, we got to find the measure of angle G. So I'm replacing this x with 50. And 50 minus 4 is 46 degrees. All right, our check coming up. Multiple choice. All right, jewelry. A designer is making a new line of jewelry with geometric patterns. My kind of jeweler. The ring shown had a quadrilateral gemstone inscribed in a circular piece of metal. And what that means to you is angle J plus angle L equals 180. Angle M plus angle K equals 180. And they want the measure of angle J. All right, angle J is across from angle L. I'm going to add these together. The 5x plus 2, the 8x minus 17, set it equal to 180. Solve for x and then plug in. Here we go. 5x plus 2 plus 8x minus 17 equals 180. Adding my like terms, 5x plus 8x is 13x. And 2 minus 17 is a negative 15 equals 180. We're going to add 15 to the other side to be with the 180. So 180 plus 15 is 195. And I put a 3 instead of a 13, my apologies. Divide by 13. So 195 divided by 13 is going to be 15. Looks like your x is going to be 15. But do not forget, they'll make me to find the measure of angle J. Angle J was the 5x plus 2. So it's going to be 5 times 15 plus 2. And looks like the measure of angle J is going to be 77 degrees. 77 for angle J. So that's going to be answer choice C. Okay, now they want us to find angle K. Well, angle K is opposite angle M. That means these two angles add up to be 180. So add them together, everybody. Set it equal to 180. And don't forget to plug back in to find angle K. Here we go. 11y plus 13 plus 12y plus 6 equals 180. We're going to put our like terms together, talking about the 11y and the 12y, which is 23y. Looks like the 13 needs to add with the 6, and that's going to be 19 equals 180. The opposite of adding 19 is to subtract 19. All right, 180 minus 19. That's going to be 161. And the opposite of multiplying by 23 is to divide by 23. All right, 161 divided by 23 is a 7. Now, don't forget, that's not what they asked for in the long run. They asked for angle K, I believe. We got to plug and chug our 7. So it's not 7. We got to plug in our 7 to angle K. So the 11 times 7 is 77 plus 13. 11 times 7 is 77 plus 13. Well, what's 77 plus 13 is 90. So it looks like angle K is 90 degrees. Okay. Oh, I am done. All right. There is your lesson for inscribed angles on 10-4. If you have any questions, let me know. Ask your teacher. We came into teaching to help you guys. Let us know what we can do to help. Y'all have a great day.